Alright, welcome to this video. This video is to walk you through the steps into incorporating electrical symbols into a new electrical plan. What I recommend first is to ensure that you download various PDFs from the course module, and so you're going to be looking at what we call the electrical code handout, as well as your electrical blocks handout. The electrical blocks handout defines what each symbol represents, and the electrical code tells you specific dimensions between various symbols for your electrical plan. It also discusses the types of outlets that you'll see on the floor plan, where specific types of outlets are required, and what types of plugs are required for various appliances. So you'll want to make sure that you review the electrical code handout sheet, which I've made for you so that you can properly install and design various components on your electrical plan. With that said, what I recommend is that you start using your floor plan as the guide and then creating a sheet with the floor plan already set up. Okay, so what you're going to do is you're going to highlight that floor plan, you're going to right click on that floor plan tab, and you're going to do move or copy. When you do move or copy, what I recommend is that you click move to end so that the new layout tab appears at the end of the line of the layout tabs. You're going to do create copy, and you're going to hit OK. And so what that's going to do is it's going to make a duplicate copy of the floor plan setup. So when I do that, it comes at the very end of the line of the layout tabs. We're going to double click that and rename that to electrical. So I'm in this specific layout tab. It looks identical to the floor plan currently. All I'm going to do here is I'm going to double click in that viewport, and I'm going to physically turn off the layers that don't need to be shown on the electrical plan. So if I go to my freeze button, if I'm in this viewport, the freeze button automatically becomes a viewport freeze. So because it becomes a viewport freeze automatically, I'm going to come to this button and I'm going to turn off the various components that I don't need to see for the electrical plan. Now, if you want to keep your plumbing items on, you're welcome to do so. But for this video, I'm going to just have them off. Okay. You have designed your own floor plan. You know what needs to be incorporated into each room. So therefore, following the guide for the various types of outlets and switches that you need to incorporate into each room, please follow that guide. All right. So here we are in our new electrical plan. What I recommend is that when you're in the electrical plan tab, double click outside of that viewport so we're ready to go, and rename that sheet so that it says electrical plan. So when we're working through various sheets, if you're not paying attention to the layout tab, you also can see it on the title block so that you know that you're on your electrical plan. So next what we're going to do is we're going to bring in those symbols from our electrical blocks template. So again, we're going to use AutoCAD Design Center. And we're going to find our file. And typically, like I said before, we like to put that file on the desktop so that we can quickly find it. So what I'm going to do is I'm going to look for that file, and it should be D60 electrical blocks. If you don't see it appear on that specific area, you can always right click Go to refresh, and that will refresh the screen. Here we are, and we want to double click that icon. Next, what we want to do is we want to come to Layout Tabs, and you'll find an eSymbols Layout tab that we can then incorporate into our current CAD file. So then you're going to left click on that and drag and drop into the current CAD file. When you do that, you'll see another Layout tab appear. So now we can close this. So that separate Layout tab is our electrical symbols. This is identical to the handout that I just went over. This handout here. So here indicated in blue, those are the definitions of what each symbol represents. So please have that on your side when you're designing your electrical plan. Let's move that over to my other screen so I can see it. And here we are, ready to go. So what we're going to do is we're going to highlight everything in that paper space tab. Control C for copy. Then I'm going to come to my electrical tab. I'm currently in paper space as we've discussed before, and I'm going to paste that information into paper space. Okay. For this video's, we're going to move this information. We're going to move it down over the viewport. And then we're going to use our command change space. CH space. We're going to highlight everything we want to move to model space, and then we're going to hit enter. And when we do that, it puts those symbols, same scale, into model space. Now we can highlight all of this text, and we don't need that text anymore. Okay, so now we have the symbols in model space, and now we can design. So what we want to do is we want to decide where we want our switches, where we want our outlets, where we want our lights, and where we want our communication. Per your handout, you can see that you have 2 rows of different types of switches. What I recommend is for your electrical plan, you're going to either show these symbols or you're going to show these symbols. Don't show both different types. The benefits of using these symbols as opposed to these symbols is using these symbols you can show with your trace wire, your circuit trace, exactly which switch should be wired to which light. If you use these specific symbols, it's the electrician's job to determine which switch will be wired to which outlet and light. Okay, so if you want control of which switch controls each outlet and light, you want to use these types of symbols. If you want to let the electrician decide for themselves, you would use these types of symbols. This symbol here is what we call our dimmer switch, and so this is for lights always. Okay. So for this example, I am going to get rid of these, and we're going to work with what we have here. Okay. And so I'm just going to move that off into space, and we're going to design, let's say, for example, our bedroom. So this, as you saw per the previous video for our windows and door schedules, this is our bedroom. So if we revisit our electrical code, you'll want to look at the electrical code sheet, and it says that outlets, if I move that into view, it says that outlets should be spaced no more than 12 feet apart on any wall. Okay? And no more than 6 feet from a room corner, unless there is a door. So with that in mind, what I recommend is we want to essentially make this layer current, and then we want to physically start to draw circles to denote where we want our plugs, outlets, and switch. okay, as well as our communication and lights, okay. So here we would want to have, if we're going to place the bed here, ideally we would want plugs for both sides of the bed, okay. And you have to include where switches, outlets, and lights occur. So you have to understand where doors open and close as well. For my specific floor plan, I'm showing doors that are barn doors. Barn doors slide. So we wouldn't want a switch right here because the door would slide in front of the switch. So you have to keep in mind of what type of feature is located in a specific area and where the switch or where the outlet would best be suited. Okay. So for example, if I wanted to think about how I'm entering this room, the door swings this way, so ideally I would want my switches in this area here. If I come through this door from the outside, ideally I would want switches on this side of the door. So typically you want switches on the side where the knob would be if the door was closed. Okay. So if I take my switch symbol, typically you want to install it at least 6 feet, or not 6 feet, 6 inches off of that door. So if I type 6 with my ortho on, it would place it right there. If I want it further, I can type 6 again, and that places it a foot off of that corner. There is no standard to how far the switch is off of specific corners, except for corners of rooms. So we're not considering this a corner of a room. The corner of a room is this corner, that corner, that corner, and that corner. Okay, so we're entering the room. I'm going to place my switch 6 inches off of the door. Now, depending on what the switch turns on and off, determines how many switches I need. So like I mentioned before, ideally it's the best method for you to first sketch each room to determine how you want the door, or how you want the switches to work, how you want the outlets to work, and how you want the lights to work. So if, for example, I was going to place a light at the center of this room, the quickest way to find a center of a room is to draw a diagonal line from one corner to the opposite corner. The midpoint is the center of that room. So if I then want to put in a fan, and I move that to the midpoint of that line, there is our fan. Now based on the size of the fan that you want to include, this is how we do this. So if I want a fan that has a diameter of 5 feet, that would be a 5-foot fan, this specific circle. Now, in terms of scaling this thing up so that it fits in this circle, we can do it a number of ways. Okay, so the fan is really the only object that will change size depending on the diameter of the specific fan blade. All of the other symbols will stay the same size. So the fan, if you're going to use fans in your house, I recommend you use the same size fan throughout the house if you're using multiple fans. So the best way and easiest way to scale this thing up so that it fits in a 5-foot radius or 5-foot diameter fan. Again, you can use a 4-foot diameter fan, you can use a 6-foot diameter fan. Most common are a 4-foot and a 5-foot. For this particular room, since the room is quite large, I'm going to use a 5-foot fan. So to scale this thing up so that it fits within this circle, we can use the align command. AL for align. I'm going to select the object I want to use to align. and then it says specify first source point. So the source is the original object. The destination point is the circle that we want to align to. So the first source point, I'm going to snap to that quadrant of the original object, and then I'm going to snap to the first destination point, which is the quadrant of the large circle. Then it says specify second source point. I'm going to specify the opposite coordinate of the original object. Specify second destination. I'm going to O-snap to that quadrant of the drawn circle. We don't have a third source point. We don't need a third source point because we're just scaling this thing and aligning it in a 2D plane. Third source point is relation to a 3D object. So because we don't need to specify a third source point, I just hit enter for continue. And now you want to say, it says scale objects based on alignment points. So what we want to do is we want to select yes. So we hit yes, and it scales the object, aligns it with the original circle that we just drew, and now the symbol is exactly 5 feet diameter. Okay. All right, so our fan is here. Let's say we wanted another fan over here. We could draw a diagonal line from here, and we can do our apparent intersection of that to find the center of this room. Then we can just copy that since we've already scaled it correctly, and we're going to use the same size fan in that room. If we wanted multiple fans in different rooms, we could do that. Once you have that component done, then you can move on to your switches and outlets. Okay, so in terms of the order in which you want to do things, it's to your choice. Again, you've tried to plan this thing ahead by doing sketches. You should have an idea of how things should lay based on what you have sketched. So based on our electrical code, it says that we have to place a plug a maximum of 6 feet off of each corner. So if I type a circle with a radius of 6 feet, that tells me that from there to there, that is 6 feet. If I want to put something closer to that corner, I have no problem in doing so, just as long as I have a plug within 6 feet of each corner. So if I wanted to visualize that I'm putting a bed right here, ideally I would want a set of outlet here for this person and an outlet here for this person. So we're going to look at our various outlets. So this type of outlet, this type of outlet would be that it's always live. Both sides are live. So if we stick our finger in there, we'll be shot across the room. If we use this type of switch or this type of outlet means that one is hot and one is not. What we mean by hot is that it's always powered, whereas the other is controlled by the switch. Okay. So if you want to control how lights turn on, so if you have a floor lamp that's attached to an outlet like this, we can control it with a switch on the opposite side of the room. If you want the light to be plugged into a hot outlet, meaning that it's always live, we can do that as well. So depending on how you want to set up this room and how you want to control it based on switches and outlets, you have that choice. Now what you want to make sure is that the symbol is always perpendicular to the face of the wall. So if I was to use this type of outlet on this floor plan, on this electrical plan, what I would recommend is copying it 4 times in your view. Then you're going to rotate this one 90 degrees. You're going to rotate this one 180 degrees, and you're going to rotate this one 270 degrees. And by doing that, this one is going to then always be perpendicular to this wall. This one is always going to be perpendicular to this wall. This is always going to be perpendicular to this wall. And this one is going to be perpendicular to this wall. So wherever you see the object and you see this line that is on the def points layer, again, this line indicates the side in which the grip is located. It's on def points, so it won't plot, but it allows you to place the symbol accordingly. So if I want to put a plug centered on this wall, I can do it as easy as that. Okay? Now remember, I'm using, for this particular example, I'm using barn doors, and they do slide. And so we want to make sure that we don't have a plug behind that if we were to open the door fully. So again, if we use a circle with a radius of 6 feet, 6 feet goes to there. So ideally I would want a plug over here. Okay? And so what I'm going to do is I'm just going to copy that and place it wherever I want in relation to that corner. If you wanted a specific distance, let's say 3 feet, for example, we can do that, and wherever the circle crosses the face of that wall, I can then O-snap and place it. Okay? So if I want a plug at the middle here, you'll notice that I have exterior walls and interior walls. If I wanted to physically find the center of between this corner and this corner, instead of physically drawing a line on top, which is hard to find and hard to see, you can do a circle. So we do C for circle, and what we're going to do here is we're going to look at the command line. The command line gives us other subcommands to use. We're going to use 2 point. So 2P means 2 point, meaning that the circle will go through exactly 2 points that we O-snap to. So I'm going to O-snap to that corner. You'll see I have control over it. And I'm going to O-snap to that corner. What do we know about a circle? From one end to the other end, or the one quadrant to the other quadrant, that's 180 degrees. That goes through the center point of the circle. The center point of the circle would be the midpoint between here and here. So I could place my outlet, if I wanted it perfectly centered along that wall, I can put that there. So I can O-snap to the center of that circle and I place the outlet. Now if I want to place other outlets, okay, so if I wanted, for example, I wanted to bring in this guy here, and I want it to have it 3 feet off of that corner, I could draw a circle and I could place it there. Okay, so just because a window is here doesn't mean that the outlet is going to sit in front of the window. Remember, windows are not only shown on the floor plan, they're also shown on the electrical plan, and they're shown on your elevations. So based on where the window is located vertically can determine whether we can put an outlet below that window. Our electrical plan is a 2D plan, meaning that everything looks flat. Okay, so just because it looks like this outlet is sitting in front of the window, it's not. The window would be above the outlet on the vertical elevation. Okay, so what we're going to do is we want to maybe put it another one from this corner 3 feet on that side. So we can copy that over there. Okay, do we want another outlet here? It's your choice, okay? As long as the outlets are a maximum of 12 feet apart, you don't need one in the middle. So if we did a distance, if we figured out the distance from the midpoint of that to the midpoint of that, it tells me it's 7 foot 7 inches. Okay, so I don't need another outlet in between. However, outlets have to be a maximum of 12 feet apart, meaning that that is the maximum distance you can have between outlets. If you want multiple outlets on this wall, you have every right to do so, as long as you meet that 12-foot maximum. Okay? And so we're going to have to have another outlet here. So I'm going to copy this or move this guy here, and maybe I have it centered about the rail and here. So again, we would do a circle to P, there to there, and then I would O snap to the center there, and now it's centered. Okay. So this is an all hot outlet. Again, if you wanted to do the half hot, half not, meaning it's going to be controlled by a switch, then that's what you would do. So if we said that we're going to control this fan with the switch, we could do that, or we could have a remote control for the fan itself and have it hardwired into the ceiling. So the fan is going to be always hardwired into the ceiling, no matter if it's on a switch or on a remote control, so that it can be powered through the ceiling. However, if you want the switch to control the fan or the light on the fan, you're going to have to draw the trace, what we call the trace wire. So the trace wire, we're going to make that current, and what we're going to do is we're going to do a spline. So SPL is the command for spline. And spline is going to allow us to O-snap to the end of that switch. And here we're going to draw a kind of a artistic curved line to the center of this fan. Now, if you just did it from the end here to the center there, you could do that, okay? And wherever you pull that spline, you never want to hit escape to get out of the command. If you hit escape, it goes away, okay? So you're going to do spline. You're going to O-snap to the end of that switch. Sometimes we like to make things a little artsy, okay? And then I would click there, and then I would hit enter to get out of that command, in which case it draws it from the end to the center of the fan. The nice thing about splines is that just because you clicked in certain areas doesn't mean you can stretch it in different fashions. So a spline will have grips on it, and so you can then pull those grips depending on how you want to adjust that spline. Okay. So that is the tracer wire. So anytime you're using a switch and you want to control a specific fixture or outlet, you're going to have to show how the switch is connected to, or which switch is connected to which outlet. If the outlets are always live, always hot, you don't need a switch. Okay. Alright, so here we've done that. We've done our fans. An air handler is some option that you can use. An air handler means that it's a heat pump that you can pump hot or cold air into a specific room instead of having a whole house system. What is the benefit of having an air handler? An air handler allows you to handle air, meaning dictate how warm or cold air is for a specific room and a specific room only. So if we had an air handler in this room, somebody in this room could have a completely different temperature than a person in this room, and vice versa. Air handlers save energy, meaning that if you spend most of your evening in the bedroom or in this specific part of the house, you only have to heat or cool this part of the house. Everything else can stay off. If you're watching TV or working in a kitchen or whatever, and you're spending most of your time in a specific room, you can then heat and cool that room and turn everything off. So it not only conserves energy, but you can have multiple rooms with different temperatures going at the same time. Okay, so that's what the air handler does. We have other symbols here. These are symbols, as you can see, per your specific legend of blocks. These are communication symbols, Ethernet. So for internet, cable TV. If you want something that has multiple options on it, surge and combo. So a surge protector and a combination with cable or Ethernet, you can have that symbol. Lights, we have a sconce. Sconce means that the light is attached to the wall. Not the ceiling, but the wall. Canister lights are what we call, a simple term is can lights. Those are lights that are carved out of a ceiling and then they sit inside the ceiling. Waterproof exterior sconce, these are typically lights that you see on the outside of the house. They have to be waterproof because if it rains, we don't want a short circuit. Typically, you will see light fan vapor combos in bathrooms. So you'll see a light that has, or a fixture that has both a light and a fan to pull moisture out of the room, but also to light the area. If you want to have a canister light or a set of canister lights in the bathroom and a separate fan, you can do that as well. So if you don't have a window in your bathroom, you have to have a vapor fan of some sort. That is code. If you don't have a window, you have to have a fan. If you do have a window, you still can have a fan. So be aware of that. Okay. Lastly, we have a garbage disposal. That's just like a generic symbol. And it's obviously that would be in the kitchen area. Now we have our outlets. Our outlets, anytime you see a symbol with 2 lines, that represents an outlet that is 110 volt. Anytime you see a symbol with 3 lines, that is an outlet with 220 volt. So based on the type of appliance that you need to plug into that will dictate whether it has to be 110 or a 220 volt. So again, if you look at the handout for electrical codes, typically 220 volt appliances in the United States are stoves, hot water heaters, clothing dryers, and HVAC, which are heating and ventilation air conditioners. Some heaters are also 220 volt. Everything else would be 110 volt. So if you're going to design a laundry room, you want to make sure that you have the correct plugs or outlets that we call them in that room to accommodate any type of setup. You don't want to just design for one specific type of setup, because if you try to sell the house or you're designing the house for somebody else and they switch appliances, you want to make sure that you have all of the options available for various types of appliances. And again, we talked about different types of switch symbols. You're going to just choose one type of set to use in your electrical plan. Some of you have asked for cabinet lights and ceiling fluorescent lights for your garage. I've provided a symbol for ceiling fluorescent lights for your garage. and under cabinet lights for your kitchen. So these are common symbols that you would see for those types of lights. So depending on where you want various outlets, switches, and lights, that is where you will place them in a specific room. Okay. So for example, if I had a multiple switch for this particular door, I'm going to move that 6 inches in so that it's right inside the door when I approach this door. Maybe I have one switch control a hot and cold outlet. Hot meaning it's always live, cold meaning that it's dictated by the switch. Okay. So if I needed to replace this specific outlet with a hot and cold, I could then just go to insert. If I didn't have it in my, because I deleted it from over here, it should be in your current drawing, and we can bring that in. It'll come in small because it comes in small if you're in the viewport, but if I'm outside the viewport and I drag and drop it into paper space, then I can come over here, move it in front of the viewport, change space, highlight it, hit enter, it comes in there, and then I can just match properties so that it's on the right layer. So if I wanted that over here, I could then rotate it and now it's a half hot, half cold switch. So you'll notice that where it's not hatched, that is a hot switch. So this is, or a hot outlet. So this is a hot outlet, that is a hot outlet. This is a hot outlet, this is a hot outlet, meaning they're both live always. This is a hot outlet, and one of them is a cold outlet, meaning it is controlled by the switch. So if you wanted the switch to control both outlets at the same time, you can do that. If you wanted, let's say for example, we had this switch that controlled, let's say one switch controls outside light, one switch controls one outlet over here, and the other switch controls the other outlet over here, we could do that. Why I would want to do that, I have no idea, but that would be an option. So if I wanted to put a waterproof light on the outside of this house, let's say I wanted it right outside this door, so I could O-snap to there, rotate 180 degrees. Don't worry about the fact that the text is upside down. We don't care. Okay. So what you're going to do here is we want to control which light or which switch controls which light and which outlet. So again, we make the trace layer current, and we want to draw a spline from here, and we want to say that this will control that. We would just hit enter. Then we want to control this, we want to use this switch to control that outlet. Hit enter. And then we want this switch to control, spline. We want to use this switch to control this outlet. Okay, so if we, again, we copied this over here, get rid of the other one, spline, hit enter, and that's how you would show that type of thing. Now if you had multiple lights throughout this thing, if we had can lights everywhere, course, I would spend the time to center these things and all that good stuff. Okay? But if we had things that are going around and trying to connect to one another, we want to make the trace wires cross as least as possible. So for example, if this was not a single switch, but it was a double switch or a triple switch, and we wanted this to control the fan, or we wanted this one to control the fan, okay? It tells the electrician exactly which one needs to be connected via trace, okay? And then we would want to physically identify or draw a spline from here to here to here to here to here to here. Now if we did that and we hit enter, again it gets confusing of what's going to what. So you want to kind of figure out the best path. We want to know that all of these lights are controlled at the same time, and we want to make sure that they go to a switch. So it's ideal to figure out, before you start wiring things together, what's the best method to get everything wired together so that your trace wires don't cross very much. So you want the trace wires to cross as least as possible. So if we do a we do a spline, if I go this way, and then I go to, for example, here, and hit enter, and then I could do a spline that goes from here to the center of the fan. And then I could say I want this switch to control that outlet, and I want this switch to control that outlet. So again, we're going to do splines, and so you just have to be aware that it will get very busy depending on the configuration that you have for this project. So if I'm saying that this switch then controls this specific outlet, it's still chaotic, but it makes it a little more user-friendly in terms of what switch controls a specific outlet or light. So again, if this was a hot and cold outlet, and we wanted this switch to control that outlet, we could do that. So again, it's your choice of how you want things controlled. If you want all of your outlets hot, perfectly fine. But remember, you're going to have some switches that turn lights on, whether the lights are on above or they're floor lights. Okay? So you want to make sure that you go through this process, go through it multiple times. If you need me to look at this, please do so, and I'd be happy to look at your drawing as you go through this process. Please reach out with questions, and I look forward to seeing your electrical plans.